All right, so I wanted to show you guys something, and also I'm getting a little bored because, as I said in one of my other videos, I had gotten a 3D printer, and I think I'm versed well enough on the software now. Now I just have to work on the hardware. I've never had a 3D printer. One of the reasons why I never got one because they were too expensive and they seemed a little bit too difficult. Now they seem to be a lot easier and less expensive. So I'm going to dive in there so that I could create rotors like this without having to do it by hand, which is kind of a pain in the butt and takes a lot of time. Anyway, this is my big rotor. I wanted to show you something I noticed on the JL94 circuit only. This doesn't happen with a Bedini circuit or using the Hall sensor. At 12 volts, if I just start it a little bit, nothing really happens. And I'm not the only one I've noticed this with. It'll continue to turn, but not really much, and then it will slowly stop. But if I give it a big spin, it somehow catches. And there, of course, is the load over there. It somehow catches, and then it really takes off. I mean, really takes off. That is a big rotor. And I have to hold it down like that, but it really takes off, and that's only at 12 volts. Now I can turn it down to 9 volts. It'll still stay connected. That's actually 10 volts. Turn it down to, there's 8 volts. It'll still run. There's 12 volts, and it really takes off at 12. But the thing I wanted to show you, let me turn it off, was that unlike a Bedini circuit, if I just go slowly with the Bedini circuit, turn it on, it'll catch it, and it will slowly increase in speed. With this particular circuit, and I've noticed Sky had to do that a couple of times too, which made me think, it wasn't just me. It has something to do with the actual circuit. Now, this is a really good coil, so I don't think it's a coil thing. I think it's a circuit thing, that it needs to get some speed. The magnetic field needs to be going at a certain speed to catch it. I'll show you again. So a little spin, nothing. Now, if this was a Bedini circuit, it would have already been flying. A little bit faster, really nothing, right? A little bit faster, it starts to catch. But if I really speed it up, it catches. You can actually hear it and see it. It's speeding up. But it takes a certain amount of revolutions. I thought that was kind of wild, and that must be something inherent in the JL94 circuit. Oh, let me turn this down. So this was the other rotor I was working on that just has the 2 magnets in it, and I very sloppily adhered these magnets to the end. I think I'm going to take this apart. I don't really like this. I wanted to use this though with the ring magnets and capture it that way, but I don't like the way I did this. I don't know why I did it like that, but I got something new I wanted to show you. Some new bearings. These are ceramic bearings, which are unbelievably cool. They're really fast. Let me pull one out here. Oops. There we go. These are beautiful bearings, and they spin forever. They're ceramic bearings, and they're 8 millimeters, so they fit perfectly on these shafts. So I think I'm going to take the bearings out of this one here and put these in or something. I'm not really sure. Something I noticed about these bearings, I don't know if it was just that one bearing, they seem to be magnetic, or at least the cases. I don't know if that's from the manufacturing process. I haven't tried putting a yeah, it's showing a little bit of a North Pole, but I don't know if they're supposed to be like that. But that's really weird. I don't know if it's from the manufacturing process, but they're beautiful bearings. And I've always wanted to get my hands on some ceramic bearings. So hopefully this week I'm going to get that 3D printer hooked up, and we'll see what we can do with it. Ciao.